Minerals constitute the backbone of economic growth of a nation, and India has been eminently endowed with this gift of nature. There are many evidences that exploitation of minerals like coal, iron ore, copper, lead, and zinc have been going on in the country from time immemorial. Recorded history of Indian mining industry dates back to 1774, when the first coal mine was permitted operation. The first organized iron ore mines were opened in 1878. Gold mining from Kolar goldfields was started in 1880. Mining activities in the country, however, remained primitive in nature and modest in scale. The first mechanized iron ore mine was commissioned in 1958 at Naumundi by a private sector company. Thereafter, with progressive industrialization, the demand for raw material increased, and hence the production of various minerals gradually went up. In the post-independence scenario, the growth of mining under the impact of successive 5-year plans has been very fast. Today, in the world mining scenario, India ranks third among global chromite producers, fourth among global iron ore producers, and sixth among global bauxite and manganese ore producers. The nature of mining processes creates a potential negative impact on the environment during the mining operations as well as after its closure. This impact has subsequently led to most of the world's nations adopting regulations to moderate the negative effects of mining operations. The celebration of the Mines Environment and Mineral Conservation Week in India has brought in an ever-increasing level of awareness and evolution of better environmental protection and mineral conservation methods. Having large mineral resources, Odisha is one of the largest producers of some of the major minerals like chromite, iron, bauxite, and dolomite. 49 MOUs for setting up of steel and allied industries, attracting an investment of about 2 lakh crore rupees, thus contemplating a steel production of about 75 million tons, are at various stages of implementation in the state of Odisha. Accordingly, environmental and conservation issues are to be addressed. This year, a total of 89 mines participated in the 14th ME and MC Week with great enthusiasm and showcased their best practices. The large amounts of overburden generated during the course of winning the mineral is systematically dumped and stabilized in non-mineralized zones. Stabilization of the waste dumps using coir matting and slope plantation has evolved to a basic standard. Overburden dumps that were once red heaps are now vast stretches of green hills. Maintaining the height of the dump plays a key role in avoiding collapse of the dump. Awareness towards terracing at suitable heights and creating step dumps is also widely observed. Having set a standard, some of the mines are seen experimenting with demo plots of bamboo and grass-laid slope stabilization method that appear to be a promising improvement. The profile of Odisha reveals that almost 31% of its geographical area falls under various forests. Industrial and infrastructure activity accounts for a certain amount of degradation. However, the mining fraternity plays a key role in compensatory afforestation program that aims to bring back the forest in lieu of the degradation caused due to mining. The barren areas in the vicinity of the mining lease, reclaimed area of the mines, colony area plantation, and roadside plantation has already spread its green cover to an extent of about 2,500 hectares, with a cumulative plantation of about 1.65 crore plants so far. Many mines allocate large areas for developing their own nurseries. Different plant species are raised for plantation requirement of their mines. Greenhouses are also seen developed to ensure survival rate of the saplings being raised, and adequate manpower is posted to take care of the horticultural activities required in and around the mining areas. This year, it is seen that some of the mines are testing and implementing a Japanese style of plant raising called Miyawaki style of plantation under technical guidance from the Ministry of Environment and Forests, Government of India. This method of plantation imitates plant growth that occurs naturally in any forest. Different mixed species of saplings are densely planted without a specific grid pattern. These plant species are generally identified into 3 tiers. Survival of one of the tier is always ensured in survival of the fittest pattern. Moreover, this year it is observed in one of the limestone and dolomite mines in Odisha that an eco-restoration program has been developed over an area of 60 hectares of mined out area. The project is implemented in collaboration with the Department of Biotechnology, Government of India and Delhi University. While the mined out pit is a water reservoir having about 3 lakh fish, the degraded land around the pit is rehabilitated with dense plantation of different varieties of grass, medicinal trees and fruit-bearing trees that are of local origin. The grass grown in this area is never cut but only let to fall and recycle by itself. The area, once home for weeds such as Parthenium and Epitorium, is today almost devoid of any weed. That speaks volumes about the significance given to the eco-restoration project. The land use pattern of the leaseholds during the life cycle of the mine leads to degradation of land as well as occupation of land by waste dumps. Reclamation and rehabilitation is mandated under the MCDR 1988. Generally, backfilling the mined out pit is a desired activity. It is observed that many mines plan systematic backfilling of mined out areas and suitably rehabilitate them. It is also observed that wherever there is scope for concurrent reclamation, simultaneous backfilling is implemented. Generally, bauxite mining and beach sand mining have ample of scope for such concurrent reclamation. This year, a total of 110 hectares was reported to have been taken up for reclamation by different mines, thus totaling a cumulative area of approximately 800 hectares so far. Conservation of the precious mineral resources is an essential part of the mine development cycle. By conservation, it is meant that the existing resources be judiciously utilized and at the same time, optimum efforts be made towards zero waste mining. Subgrade mineral and low-grade minerals that do not have market presently are stacked separately for utilization in the future with the advent of newer technology. A few pelletization plants have already come up to utilize the low-grade finds and many are in the offing, which is in the right direction from mineral conservation point of view.
आमे एठी निकेल फेरस लिमोनाइटिक जो मटेरियल हमर माइंस रु बाहरुची आमे ताको एठी डंपिंग करी रखुचु निकेल जते बेले यूज आसीबो से समय आमे एठू यूज करिवु.
In the case of chromore mines, nickelferrous limonite with likely recoverable nickel content is systematically dumped and preserved separately. the possibility of recovering nickel from the limonite material is being studied. Breaking, crushing, loading and all handling activities involve dust generation in the mines. Therefore, many dust suppression methods have evolved and already set standards in the mining industry. With the haul roads being a major source of dust generation, almost all mechanized mines today deploy the motor grader and water sprinkler combination to maintain a smooth, leveled and dust-free haul roads. Moreover, many mines have installed permanent water sprinklers that sprinkle water on the haul roads at automatically timed intervals. Moisture retention on the haul roads is elongated by mixing permitted chemical agents with the water being sprinkled. Moreover, soil cementing using synthetic polymer is successfully implemented in one of the mines. Polymer compound is mixed with water in appropriate ratio and sprinkled on the haul road in periodic intervals. The polymer material is reported to be creating a bonded layer that make the haul road as good as a blacktop road. However, the haul roads maintained using the polymer technique are suitable only for wheeled equipments. A few years ago, drilling of blast holes involved a lot of time and also generated a great deal of dust. Many mines today deploy state-of-the-art machinery for drilling blast holes. Deployment of high-speed drills with inbuilt dry fog and back filter system is gaining popularity. In some cases, crushing plants are also observed with a standard back filter system that sucks out dust of various sizes and disposes them safely. Many mines are seen to have deployed the advanced dust samplers as per the revised guidelines for dust sampling and ambient air quality monitoring. Many mines today have chalked out their own systems of rainwater harvesting and groundwater recharging. Mines having their own residential colonies are observed to have designed and implemented rooftop rainwater collection for groundwater recharge. A number of soak pits and recharge tanks have also been constructed. This year, it was observed that one of the chromite mines has indigenously designed and implemented a rainwater drainage system to manage the rainwater catchment in the waste dumps. Wide garland drain is constructed around the toe of the second level of the overburden dump. The garland drain is connected to a collection chamber built on the top of the first level. A pipe of 18 inches diameter is in turn connected to the collection chamber that runs underground on the first level and runs along the slope to a settling pond at the bottom of the overburden dump. The water that is channelized through this closed pipe is then let into an ETP built near the settling pond. The amount of silt seen deposited in the garland drain and the settling pond speaks volumes about the effective reduction of silt that could have otherwise been carried away. This system appears effective in managing rainwater in multi-level overburden dumps. Employee welfare in the mining industry is one of the most essential activities of mine development today. The miners that make mining possible are required to live in remote areas.